it's all right with you. So the big thing I want to talk about today is I really want everyone to kind of do a little bit of thought exercise of what kind of things keep you from moving about twice as quickly in a mobile development environment, right? So I don't mean necessarily like what keeps you from writing twice as many lines of code, but what keeps you from writing twice as many features. I'd argue that it's not problems with Java or problems with Kotlin or problem with whatever language you're using. It's probably not even the amount of boilerplate that you have to write. Like I can crank out a getter pretty fast with IntelliJ. Like it's not something that particularly slows me down. The main issue that I have and that I've seen is that most of the time when you write code, you don't know what it's doing under every circumstance, right? You have some idea what it does in the happy path. You might even understand one or two error cases, but you really don't understand every variation that you could possibly encounter in your code. And as a code base grows, you often don't understand how all the pieces relate to each other. In some ways, this is a good thing. You don't want to have to hold the entire state of the world in your head. You don't want an app to be limited by how much you can understand about the relationships between classes and frameworks and things like that. But it means that it's difficult sometimes to drop into a code base. It's difficult to drop into a code base and figure out what's happening. Can I get at a manager factory impl abstract class, and what does it do when I actually get it? So I want to talk about this a little bit in the context of Uber. I'm particularly passionate about this both because of our scale and because some of the unique challenges the app has. So the app actually works in a very small number of screens, right? You have kind of like the looking screen, you have like requesting screen, you have like a pickup screen, and the partner app is very similar. You have a mode when you're offline, you have a mode when you're actually taking somebody on a trip. So it's a really small number of screens, but a large number of problems. How do you handle cash payments? How do you handle rickshaws? How do you handle issues in India, issues in China, issues in different places? So the number of issues is high, the scale is big, and the number of screens is small, which means there are a lot of sort of unique problems. Some of these things are a little easier to solve also when things move a little more slowly. So this was the entire Uber mobile team, I think about 3 years ago-ish. Right, so all the people you can see in this picture, all three. This is, I believe, iOS and Android. It might just be iOS. It doesn't really matter. It's not many people. Today, it's more than 100 on each platform. Right? So in 3 years, that's a pretty phenomenal amount of growth. And again, a very small amount of screens that form the primary backbone of the app. There's a lot of other features that are in different screens, but a lot of the main traffic of the app is a small sort of area. So the typical approach at scale, when you go from something like this to something larger, is when people join, you tell them, hey, use this thing. Like, don't use X because it's bad, use Y because it's better, and sometimes they kind of understand, sometimes they don't. That approach scales actually really poorly if you grow quickly, right? So if most people have not been in this code base for more than a month or so, like you can't count on there being a ton of old timers to explain everything to them. You can't count on there being a lot of established best practices or other things that you do. And honestly, it's not that great of a solution anyway, even for people who grow slowly. Like I don't want to have to ask somebody what I'm supposed to be doing. I want it to be obvious. I want the code to tell me. I don't want anything to compile if it's not the right thing to do. So the goal here is to tell you some of the things that Uber did to solve these kind of problems. Not everything. There's like probably 6 talks that we could do about this. I'm not going to touch build and release and all the safety you get from that. I'm not going to touch mostly some of the core architecture pieces that help you make right decisions. What I want to do is introduce a number of tools and a number of best practices and things you can do that will help get you the kind of safety that I'm talking about. And also how these tools work together. Right? So the tools are interesting. I'm going to go over them. I'll go over them quickly. Maybe one of them will be new. Probably 2 actually for most people in the room. The third one probably not so much. But the really fascinating thing, the really interesting thing is how the tools work together. So the tools actually complement each other, and the processes complement each other to be better than like each one on its own. So it's easy when thinking about a problem to think like, cool, I can drop this thing in and it will be solved. Confidence is not that way. Like you can't just say, I'm going to drop in Dagger 2 and now I will be confident that all of my code works. Like that doesn't happen, right? It's nice, it's awesome, it's something that I'm going to talk about, but it doesn't just like magically appear. All right. So the other interesting piece here is how you think about bugs or problems as you grow, right? So in this example here, when does this function get called? Does it work? Does it not work? It's actually really hard to tell. Like if this is a callback and the fragment is detached, then no, it doesn't work. An activity is null and this will crash. Like, how do you know that? Like, what would have told you that that was the case? Like, this is very difficult to figure out. And who's fixing this as a systematic thing? Like, how many people have wasted time on bugs that come from fragment callbacks? Like, in the apps that you're working on, who is fixing those problems? Is it just that every person learns through really painful trial and error that all of these things are really hard? Like, what are you doing to keep this from happening in the first place? It ends up being a lot of wasted effort. So this is a little bit of just the Android team, like, I don't know, 6 months ago maybe. And one of the things I'm really trying to sell you on here is that confidence and safety is actually one of the things that helps you move quickly. By not spending time on tracking down crazy bugs and all of these other things, you can actually move a lot faster. Like if you have to write 3 more getters and you don't have any bugs, like you're gonna be like 100 times more productive than if you focus on like some new crazy thing, like eliminating like every possible line of boilerplate. Like you really do wanna think about what it would scale to 500 developers, even if you have no intention of scaling to 500 developers. Because what that tells you is these are the things that I expect people to get wrong in some amount, some frequency, right? If the number of developers is like 5, 6, 10, then if the frequency is low, like maybe you don't care a ton today, but it's still wasted time. And as you scale, those things get worse and they get more severe. So a tiny bug that one person might have caught, maybe the next person doesn't catch and it becomes like a real issue. So my goal here is not to convince you that all of your apps should try and scale to 500 developers. Like Uber does not have 500 developers on an app. Like that's not the scale that we're at. But when you think about things in that way, you think about places that people waste time, just like thinking about what would make you twice as productive. So a couple of the things that we found are really, really important here is the bias towards understandability. So when you look at code, can you understand it? Do you understand what's happening? Otherwise, you end up wasting a lot of time tracking things down. A strong reliance on compile time safety. The compiler is fast, almost everything else is slow. Runtime is slow. The big elephant in the room for this talk will be testing. I'm not going to talk about testing at all. I like testing, testing's great, it's nice, but it takes a lot of time. I'd rather not have to test. If you could tell me something at compile time works and I don't have to run a test anymore for it, like that's better. I don't think we'll get there, so like, yeah, let's test, but I'm not going to talk about it at all. And this is not a bug fighting talk. Right? Like my goal here is not to like just tell you ways that you can like eliminate errors in your code. My goal is to show you when you start coding, there are certain things you can do to help you actually understand what's going on. There's a side effect, yeah, but the goal is to help you move quickly. And sort of the big question that is a useful thing to sort of ask yourself is, assuming good people, assuming that you have awesome coworkers like I do, can someone land in the code base and help more than they hurt, right? Business logic is arbitrarily complicated. Like if you have some sort of crazy business logic, like I can't help you there, you know, you made something super complicated, then fine. But general engineering, general ways to stitch together apps, like there are frameworks we have for talking about that. All right, so annotations. So this is not an actual code in the Uber code base, but it is incredibly similar to actual classes in the Uber code base, in which everything is annotated, right? So annotations are the first tool I want to talk about that help get you this kind of safety, right? This to me, I love this code. This is beautiful code to me, right? You can see every single field, you have some indication of what it does and what it's supposed to be doing, right? You see here, get satisfaction, right? It returns a string. Without annotations, what the heck is that? I have no idea what that means, right? It's a sum string, I don't know what it could be. Like, is it A, is it B, is it yes, is it no? Like, cool, it's neat conventions. Somebody goes and adds another value, now what happens? Like, were you checking for that? Can it be empty? I have no idea, right? So you have other things here like a color resource, a style res, which I don't actually advocate putting in a data model. It's mostly just for illustration, but and then you look at the things here at the bottom, like latitude and longitude. This is a great example of something I see in many, many, many code bases. You pass around int latitude. Okay, cool, what is that? Well, what is the actual range on a latitude? Actually, most people don't know. And what will happen is you'll assign a longitude to a latitude and you'll never know, right? Like, they have different ranges. The compiler can tell you this. Lint can tell you this. They can tell you that you've done something wrong if you will go to the effort to tell the code what you meant to actually do. Look, this is a latitude, and I always get it mixed up, which is one of the reasons I love this annotation. Yeah, it's from -90 to +90, right? That's the range of latitude. The range of a longitude is -180 to 180. If you try and assign a longitude to latitude with this annotation, the compiler will in fact give you some warning, or the IDE will give you some warning. You'll have some hope of catching this super subtle bug. Okay, so there's like a ton of these annotations. I would be willing to bet that almost no one in this room actually knows what all of them are, right? Like, while the difference between UI thread and main thread may not be particularly fascinating or useful, like, there's like worker thread annotation, and there's all of these ranges and all of these resources. Like, they're super, super useful things that people have gone to a lot of trouble to bake these into the framework and make them useful. So that's kind of enough review, but one of the big takeaways here is whenever you're passing around like an unannotated integer, oftentimes there's something wrong. Like if you grep whatever code base it is you work in right now and look for an integer parameter, I'll bet you 10–20% of them, if you don't use a lot of annotations, really deserve one, and it's something that you can add very easily to get yourself some safety for things like this. And this is a bug that I hate. It's bitten me a couple of times, and it is one of the most frustrating Heisen bugs you'll ever see, is when you try and put a color resource in as an integer. Sometimes this actually works, which is insanely, insanely frustrating because you get some color that you didn't expect. You get some weird grayscale thing and you were looking for red and you have no idea why. Well, it's because you passed a resource in instead of a color in, right? Look, the IDE tells you, like if you just go to a little bit of trouble to tell the code what it is you're trying to do, the IDE will help you. Like it will keep you from making mistakes, which is wonderful. All right, you went to all this trouble, you annotated your code base, like there's semantic meaning. It helps humans, by the way. You look at other code and you know what someone was trying to do. Oh, I see this is a latitude. It's very obviously a latitude. They were trying to do this. It can be more than just an IDE hint though. Right? You went to all this trouble. You told the code what it's supposed to look like. Why is nothing enforcing that? Right? Like the IDE will help you with some things, but not with other things. So for instance here, let's say that you got this model from the server. Right? My model is like something that's returned to you in JSON, and you use something like retrofit and a JSON converter to make this model. Right? How do you know that this customer satisfaction field actually is one of these strings? You said it was supposed to be, but how do you know? Like, how are you actually sure? Right? So there's some solutions for this that exist in the world. There's things like thrift. There's things like protobuf. You can serialize some of these things. They do have some downsides. They make some changes to the program. Sometimes you lose annotations in the generated code. I don't want to talk about all the problems with that right now. But you know, they're not typically used for things like storage in a lot of cases. You know, we can talk about some of the downsides later, but what if you could just take these annotations that you already put in and actually check them? And that's actually one of the things we did. So internally at Uber, we have a tool called RAVE, which is an annotation processor that looks at your models, and that's what this annotation at the very top is. It looks at your models, and it checks that the annotations that you gave to the model are actually fulfilled at runtime. Right? This is not particularly like rocket science. Like you can imagine what this code would look like. Okay, I see a string def here. When I make my model, I will look and see, is the string in this field one of these three values? Yes, no. Right? It's not something that's very difficult for like a human to understand, but it's information that you've already given to your code that nothing is utilizing yet. So this is actually a pretty cool tool, right? We have an annotation, the concept of an annotation processor in Java. We have the concept of an annotation. Not a ton of work has actually been done in bridging like runtime checks to make sure that it actually is used. So this is actually useful too for more than just like network models. Let's say you store something. Let's say you mutate the state of objects in your system. Let's say you have some class that has field annotations internally, that some things are non-null or nullable. You can check to see if those things are actually true. Is what you said the code was supposed to be doing, what the code is actually doing. And you can do it more or less for free. There's not very much cost to this. You already did the work to annotate, just check. So it's actually a really pretty neat annotation processor. So you can check things like string def, right? You can check things like int range. Is my integer between these ranges? Like how many times have you passed around an integer without an int range annotation? Do you really know nothing about that integer? I'm super skeptical. Like, can it really have any value from min value to max value? Probably not. It's usually, the minimum is usually 0, the maximum is usually something insane, 256, 1,000, 10,000, right? Like, you have these sorts of things. You have like a length for strings and for arrays. Like, Usually you're expecting something more than one. Most strings actually you don't want to handle empty strings, or you don't want to handle null strings. Like, all of that information is information that you have in your head when you code, but not as many people put that actually down on paper. And you can go even further. So we actually have some custom annotations that are not in Android. Things like must be true, must be false. So you can take any of these states of the system and attach any arbitrary conditions to them. Here's an example of something that I think is useful. Right? These are approximately the latitude and longitude coordinates of a big swath of Atlantic Ocean in which there is no landmass. Right? So if you were to put this annotation on one of these models, so let's say you get a latitude and longitude from the server and you add this function, what it will do then is at runtime, it will look and see if the latitude and longitude you got is in this huge square of Atlantic Ocean and complain if that's not the case. Right? So must be false. Basically, the longitude and latitude must not be in this square. These are useful things because you're telling Java this is the state. This thing must always be true. Like something must always be the case. So there's a lot of actions available to you with these tools then. So you have all the standard Android annotations, which you've probably already done. You can just drop an annotation processor in and get this for free. And you can then add custom business logic. You can say either A or B must be true or false. And these are the types of things that are more difficult to do in something like Thrift, right? So at Uber, in fact, we page for this. When these conditions are violated, someone's get paged, right? Something has gone very wrong in the system somewhere. Like, somebody needs to know about this, which has actually been really effective. And there's a lot of things you can do about it. So how would you even integrate this? Well, it's actually not super hard. You already have touch points in almost every system that takes some network response and turns it into a POJO, right? All you have to do in that system is check that the validation succeeds, right? These annotations that you have are satisfied whenever it is you deserialize these things from a network or from storage or wherever it is you're getting objects from. It's just one example. The point here is you did the hard work to tell the code what you're trying to do, now leverage it. The other interesting piece that I want to talk about here is Infer. So it's a static analysis tool from Facebook. Other people will talk about this in much greater depth, but it's fairly interesting. So it does a lot of things. It detects a lot of bugs. It's kind of a grab bag, actually, of tons and tons of different things that works really well. But the most common use case is null pointer exceptions. Right? Okay, this is an obvious null pointer exception. You said that some parameter was nullable. You immediately dereferenced it. Like, cool. The IDE warned you. I would argue that the benefit you get from Infer in this case is minimal. I mean, the IDE doesn't enforce anything at compile time. It's nice to not have any warnings in your code. But like, hey, the IDE is already telling you about this. Neat. All right. Another particularly interesting bug, you have some class, you subclass it, you change the nullability of a field, or you change the annotation on some sort of field. These are actually really subtle and really annoying, right? So your superclass or your interface has some contract. It says like get foo, right? Everyone who implements this has to implement get foo. And get foo really has to be not null. And everywhere in the code that you use get foo, you're really assuming that it's not null. Somebody overrides this and said, well, for my case, it might be null. I'm going to just go ahead and make it nullable. It's fine. You want to detect that sort of thing. Like that's an easy thing to miss, it turns out. But the really crazy thing Infer does, and this is where it gets really nuts, is it actually catches missed annotations. Right? So if you take a look at this code, right, return something can return null. In a certain mode, Infer will actually complain. It will say you are returning null and you are not annotating this method nullable. Like you messed something up, right? Which is interesting. But it will also catch this in longer chains, in very difficult chains to find out. Like there have been quite a few cases where Infer has complained to me that something should be nullable, and I disagreed with it. And I looked for a while, for maybe 5 or 10 minutes, and eventually concluded that yes, it actually could be null in some crazy situation that I hadn't thought about. This should be surprising. This is actually pretty hard to do. This means that Infer is actually doing some really interesting analysis of your code. It's actually looking at what your code can do. It's not just like doing something like lint, where it's looking like, oh, let me look at a couple of branches and see like what's happening. This is actually looking at how functions relate to each other and return values and these sorts of things, which is really cool. And it's also super, super useful for humans. One of the things you'll find is when you design APIs, it's very easy to make an API that is way more stateful than it should be, or does weird things in weird circumstances. Like you have to call function A before function B. Like you get in a hurry, you start to make bad decisions like this. Infer will actually keep you from doing that. It will say like, look, you said this function had to return something not null. but it actually can be null if you didn't call this other function first. And you'll have to take a look at your API and figure out what you did wrong, why you made it too complicated. Okay, so in practice, there are some good things, there's some bad things. Some engineering is required to use Infer. There's now, fortunately, publicly available homebrew formula, so you can actually brew install Infer now, which is really, really useful. That was something that someone here contributed that was really cool. You know, you may have to do some Gradle work to get Infer to work for you. It's actually, we did the work to write a Gradle plugin internally that was pretty cool. And some of the build times as codebase gets bigger, get a little bit longer. You can do some caching of results, but because Infer does actually really deep analysis of your code, it does take a while to run. It's actually doing a lot of work. It's not just like dorking around here and there, like just looking at files. Like it's actually analyzing how flow works in your code, which is pretty neat. All right, so this is like a sample Infer run, a sample output. This one is catching two errors. One is catching a null dereference, which is like the very classical thing that we've been talking about. And one is actually catching a resource leak. So I mentioned at the beginning that Infer is kind of like a grab bag of a lot of useful stuff. It will actually check to see like if you're leaking context or leaking resources. So sort of I think the quip here is like you come for the null, you come for the null dereferences and you get a lot of other stuff for free, which is nice. Yeah, so at Uber we actually use this to automatically analyze every diff that goes up. Right? So whenever you put a diff up, we actually check pretty deeply for null pointer dereferences and a lot of these other kind of bugs. And it actually catches quite a bit. It's surprising actually how thorough Infer is. So it's a tiny plug for Infer. Dagger 2 I'm mostly going to gloss over. Right? Dagger 2, there are much better talks on this. If you're looking to this talk to teach you Dagger 2, you are sorely going to be disappointed. But the one thing I did want to introduce is that in these classes of tools, there are certain things that each tool does that almost nothing else can bring you, right? So like Rave is something that we built because there was nothing else that looked like it could do that, right? Take all the annotations that we try to put in and actually like validate them. Infer, I don't know of a whole lot else that does this kind of deep analysis. There's things like find bugs and PMD. We found Infer to be actually quite a bit more thorough and do things like tell you when you're missing annotations, which is really awesome. Dagger 2, I'd say like the big piece that you don't get anywhere else is scopes and scope safety. There are not actually that many ways to reason statically about life cycles in an application, right? So you can say like my A creates a B, creates a C, and I only want the objects that C makes to be around while C is alive, right? There are not actually that many tools to help you guarantee that that is the case, right? And so what will happen is in a large application, especially someplace like Uber, where you have a couple of screens, you'll have a whole bunch of objects come into the screen, and then someone will click a button, and they all go out, and a lot of state gets torn down and created without a tool to actually tell you with some sort of compile time safety that that's going to work out the way you hope. Someone new landing in a code base is going to have a really hard time understanding when and where and how they can allocate and deallocate things, like how long can something stick around for, like when is it good. There's a ton of things. Dagger gets you, non-circular dependencies, a lot of compile time safety, no reflection. It's super fast. Like when we went from Dagger 1 to Dagger 2, I think we dropped like a second off our boot time. I mean, it shouldn't have been that big, but it was actually quite large. A lot of these things are unique to Dagger is really the big point. And the other piece that's actually really interesting here, and the same theme of annotations, saying something that a human can understand. If you look at this component on the screen, this actually tells you a lot about what you're exposing. Like you're saying this music service component is responsible for providing location data in a model, right? This is actually a really, really nice touch point for a human to understand how data flows in the system. You have to like take a stand in these components and say like, this is what I'm exposing. And more explicitness does help you move with a lot more safety. If I have this component, I know that I can get these things. I don't have to wonder about it. I don't have to question about it. If it compiles, it works. Right? I love Dagger 2 so much. I would love to talk to you about Dagger 2. It's very fun. I love things that work at compile time. Here's an example. Right? It's easy to add another dependency. If you want to add inject A, you can do that. It'll either compile or it won't. If it doesn't compile, you'll have to do a little bit of hunting to figure out why, but if it compiles, you can get it, you're fine. Right? It's hard to mess up the scoping. It's hard to mess up the dependency relationship, mostly. And there are not many other tools that help you with lifecycles. All right. It's not all easy, though. This is what your IDE will often look like if you're using Dagger. If you're not familiar with this, then I applaud you. You've somehow solved some problem that I haven't seen a good solution to. That's why you see APT in a lot of the Gradle scripts to set up this like pre-compilation of a lot of these components. And how would you test this? If you're going to test a class that has this on create, like what would you do? Would you override it and you have to kind of provide an alternate component? Like the testing story here is hard. And I'd love to talk sometime else about some of the things we've done to solve that, what worked well and what didn't. There are definitely some things that don't work that well. But it's not all roses, and those are some of the things you would expect to see. All right, so there's so much more. I'm not going to talk too much about them. Lint fills in a lot of the gaps. I love this string format bug. This thing drives me nuts. You forget to pass a locale into your string format, and like in some languages, for instance, things aren't represented with decimals. They're represented with something else, and somebody else tries to like slice a string based on where the decimal is, and it no longer works when you're in some locales. Like, I hate this stuff. This stuff is so frustrating. Lint will tell you. I mean, all you got to do is ask, and most of the time it's just because people don't want to convert old code to not have lint warnings. It does a lot. Check style, nothing slows you down like a flame war about, about formatting. I've been at some places where I remember there's like almost an entire week of lost productivity because everyone was like flaming each other about code style. Like, it's not good. Like, just set something and move on with your life. Like, most of it is fine. Check style just shuts all of these discussions down and no one has to worry about it. It's wonderful. And Gradle, I'll talk a little bit more about this, but there's a lot of things you can do here to enforce consistency of your code base with your build scripts. All right, this is really I consider this like the payoff slide of the talk, right? Like, I introduced some interesting tools. Rave is new and novel. I think it's pretty cool. But how do they combine, right? So I just told you how to solve like a bunch of isolated problems, but what does this get you in like a code base together? All right, so what Rave will do is it'll set a baseline set of expected states. You can say, look, I can express what I expect my code to be doing with this set of annotations, and then Rave will enforce that that's actually true. So you know in your code, look, this is the starting state for sure. Right? I can tell you that this is the starting state, and must be true, must be false, plus all of the Android annotations. You can express pretty much any arbitrary thing you want. So any type of starting state that you want to talk about, you can do with annotations. Infer then takes that starting state and checks how it propagates through your code base, right? So if you have something that's marked nullable or non-null, Infer will make sure that from the good starting state that it flows through your code base in a predictable way, right? So this is like the next step in the chain. Dagger gives you a lot of things. It'll tell you a lot about lifecycles, but it'll also mean that it provides a way to keep that unbroken chain from Rave with Infer through your application because it's all compile time, right? There's no reflection anymore in Dagger 2, which means that a static analysis tool knows enough to actually do the analysis. It also means that because Dagger understands a lot of, not a lot of, it understands enough of nullability not to let you create null objects, it won't break that chain, right? And lint fills in the gaps, right? So the first three are very deterministic. They will always work. You should listen to everything they're saying. You should not drop stuff on the floor. It's all good. Lint is probabilistic. Lint can sometimes be wrong, but it fills in a lot of the gaps. Like string format, none of the things I talked about before would help catch that. None of those tools understand what an Android locale is. Like, not going to help you there. Lint, people have done just a phenomenal amount of work. If you haven't, I would actually suggest that you look at all of the lint rules. There are a ton. Somebody did just tons of work there. I would love to, I would love to buy them something someday. Thank you so much for doing that. So here's some examples, right? See this @initializer function? This is something that's provided by Infer that will let you know that you should treat this function as the constructor for your object. So this helps fill in the gaps for things like activities, right? The constructor of an activity is not what you plug into. So if you annotated all your fields as non-null, right, and you had an empty constructor, well, I mean, you've just immediately broken all usefulness in static analysis, right? Because you have these fields that you have to treat as non-null, but you actually can't make them non-null in the constructor because there's no arguments. That's terrible. So there's this annotation called @initializer in Infer, and what it will do is it will treat things like onCreate as an initializer, as if it were your constructor, right? So you can really shoot yourself in the foot if you introduce like an empty constructor and try and dereference a field. I've never actually seen anyone do that, which is impressive. I've worked with a lot of developers. I've actually never seen anyone make that mistake. So this seems actually like a pretty safe trade-off. This is the type of synergy you get between Dagger and Infer. Infer even supports like the @bind annotation for butter knife, so if you're using that on your fields, Infer will know that to treat those as non-null. It treats @inject as non-null because it knows that Dagger will return not null things. Like just a lot of really good stuff that actually works really well between these two tools that kind of keeps this unbroken chain for you from start to finish of your application. How does Infer work with Rave? Well, remember when I said before that Infer will actually help you catch missing annotations? Right? It will actually tell you when you're missing nullable or you have a non-null where you should have had a nullable or nullable where you should have had a non-null. Like it'll help you fix these things. These actually work incredibly well together. Right? Rave will actually check all the annotations you have. Infer will tell you all the annotations you're missing. And all of a sudden these two tools are building on each other. Right? So Rave will tell you more things about your starting state the more that Infer fills in. And then once Rave can tell you more things, Infer can catch more things. So it's actually a cycle. So you can actually start with a poorly annotated model. Infer will tell you some more things you're missing. You go add the annotations. Now Infer can tell you more about your code. Like they build on each other in a really, really interesting way that is incredibly, incredibly helpful. So the last piece that ties it all together is Gradle, right? You have all of these nice best practices. You have all of these nice things you're doing. You've applied all of these lint rules, all this really, really cool stuff. How do you make sure that in a large code base where you have a lot of libraries, a lot of applications, a lot of modules, how do you make sure that this is happening everywhere? That you don't have one group off here running on the side and they don't really understand all of these pieces. Gradle is a wonderful way to bring all this stuff in automatically, right? Gradle is super extensible. There's a lot of capability for writing plugin. So at Uber, for instance, like let's start with the string format bug, right? I hate the string format bug. It makes me cry. You know, we fix it in one place, like, oh shoot, we didn't apply the lint rule in this other place. Like, oh, it's really frustrating. When you control the Gradle build scripts, when everything is using the same build tools, what you can do is you can apply that lint everywhere and just start fixing things until everything compiles again. Right? Like lint will tell you a lot of these things, but you need some way to apply this kind of uniformity across a large code base. Again, there's kind of this concept of the unbroken chain from like starting state to end state with this analysis. Gradle is a nice way to make sure that you're actually applying all of these things. So it's not a particularly like fun and new and cool thing, but like Gradle plugins actually can be really useful as a tool for doing this and a tool for consistency that's really, really useful. It means that it actually can give you warnings that won't be ignored. Cool. So there's a lot of other things we do. I'd love to talk about all of these. There's not enough time, and frankly, it'd probably get a little dense. View-based development, I love this. Someone's giving a talk on this right now. I hope that we will give a talk on this soon. Lots and lots and lots of stuff there. But the sort of the big takeaway with a lot of the view-based stuff is like, there's a lot of frameworks. They're basically something Pojo-y, something fairly light, something easy on lifecycle, something that makes testing a lot easier, a lot of these sorts of things. And that's it. So basically the real big takeaway that I wanted people to have is that a lot of these tools, while interesting in isolation, and they'll solve some problems for you in isolation, they combine to make the entire development experience a lot more, you can be a lot more confident in your entire development experience. So when you make a change somewhere, if Infer is running, you'll know if you broke some chain that you didn't know about. You'll know if someone forgot some annotation that you weren't expecting. You'll know if you make some sort of server model or network model that doesn't match what the server is sending down, even if it's like a JSON API that you don't control, you can know that. There's just a lot of ways to get a lot more knowledge. And annotations are like a wonderful place to start with that. So it's a way that you can tell the code what it's actually supposed to be doing. With the goal to make people move more quickly. So much time gets spent fighting frameworks or debugging. You really want to try and minimize that time as much as possible and have some idea what's going on. That's all I had. I love talking about this stuff. Please find me afterwards if you have any interest at all in this. I would love to talk. We'll be at some of the booths around here. But thanks. That's all I had.